Well, hi everyone, this is Bob the Science Guy. You know, for the last few days, the news has just been awash with reports of an interstellar visitor coming through our solar system. We didn't know if it was a comet or an asteroid or what. Well, it got my curiosity piqued, so I went ahead and I looked it up and I found that it was a magnitude 18 object, and that's well within my capabilities here at Shamrock Banks Observatory, so I thought I'd have a look. Now, I looked up the ephemeris, or the location of where I needed to point my telescope from my observatory here in Michigan to see this object. I dialed it in and I took 36 2-minute images of the object for a total of 68 minutes. Then I ran them through a program called Tycho Tracker, which is what I use to determine the orbit of asteroids that I find. Basically, what it does is it compiles all 36 images and then looks for anything that's moving and tries to match it up with a known object such as an asteroid or a comet. Now, as you can see here, it found a dozen or so high probability hits. That means that these are objects that are moving, appear to be solid objects, and are high probabilities of being an asteroid or a comet. And if you have a look, you'll see that all of them have names except for one. Well, I went ahead and measured each of these named objects and sent my data off to the Minor Planet Center. And then I had a look at this unknown object. Now, the thing that kind of struck me was the speed of the object. And notice all of these objects are moving at less than 1 arcsecond per minute. These are very typical of what we call main belt asteroids. But when you go over 1 arcsecond per minute, you start looking at near-Earth objects. So this was a lot of interest to me. So the next thing that I did was I looked at all of the images of this object stacked on top of each other, and you'll notice it seems to be a nice discrete object. It's not a streak of any kind. It looks like this is an object that the computer is actually tracking. So here's the raw image of my star field, and you'll notice that the cursor, the centroid here, is pretty much in the center of the image. There's a little more image below the screen here that you can't see, but that is pretty much dead center in the image, and that is exactly where I was looking for this object. Now, if I zoom in on it a little bit, it becomes a little bit more interesting. Notice that the stars are streaked, and that object is a discrete little dot right in the centroid of the field. It is basically heading towards the sun. This is the direction coming from the sun here, and its velocity is 1.26 arcseconds per minute, which is indicative of a near-Earth object or a very fast-moving object out in the main belt. Now, if we zoom in a little bit more, we can see that very clearly this is different than the stars, and it's also very consistent. Now, the way that we do observations is that we look at the right ascension and the declination of the object that we're looking at. That's kind of the celestial equivalent of latitude and longitude. And then we add the parameter of time. So by getting 3 different observations of an object at different times and incorporating all 3 of those elements, we can actually solve for the orbit. Now, there's a couple of interesting things that you'll notice about this. First of all, as we noted, the speed is about 1.26 arcseconds per minute, which is approximately the reported speed of this object. The other thing is the object is reported to be approximately magnitude 18. And as you can see from the magnitudes here, that's looking pretty good. So I went ahead and reported my findings to the Minor Planet Center, and they did indeed confirm that what I captured was this object. Now, as I said, the object was discovered on July 1st, and since that time, there have been approximately 250 observations of the object by both professional astronomers and amateurs like me, and I am included in that group. And that has enabled us to learn an awful lot about this object. This is JPL Horizons. This is the Jet Propulsion Lab in Pasadena, California, and they maintain a database of small bodies in the solar system. So I did a small body lookup, which has subsequently been named C2025N1 Atlas. And if you look at this, you'll see the interesting thing about the orbit of this body is that it seems to come from outside of the solar system. It's going to make a turn about the sun and gain a little speed from that, and then it's going to exit our solar system. Now, one of the things that we can plot from this is the actual trajectory of this body. Now, before anybody loses their mind, this is not going to come anywhere close to hitting Earth. It is going to come relatively close to Mars. Here's the body, and here's Mars. It's going to come relatively close to Mars in September, and if we continue this along, it will become relatively close to Jupiter in March. Now, the thing that you should note is that Earth, during this period of time, is on the wrong side of its orbit. By the time it starts coming out here by Jupiter, we're going to be able to actually see it in our night sky. Whether or not it'll be visible to the naked eye, I don't know, but it might lead to some nice images as it approaches Jupiter. We may be able to get the comet and Jupiter in the same frame through my telescope, assuming, of course, the Michigan weather cooperates. Now, initially, the composition of this object, of course, was not known. It was just discovered this month. However, one thing that did strike me and a lot of other astronomers was how bright it was. Now, subsequent studies have indicated that the surface of this object is primarily composed of ice. Hence, it's very reflective and bright. And yesterday or the day before, an observatory did note a small tail about 3 arcseconds long. So, as it turns out, this is a comet. What's interesting about it is that it's from outside the solar system and doesn't appear to be coming from the Oort cloud. This is an interstellar object, and it's only the third one that we've discovered, all of which, I might add, have been within the last couple of years. Now, let's talk a little bit about how asteroids are found. Now, there are several government sky surveys out there. Atlas, for example, which found this object, is one of them. Those consist of kind of medium-sized optical telescopes that do wide field images of the sky. To give you an example of what a wide field image of the sky is, if you look at the James Webb Space Telescope, which sits out at L2 beyond the orbit of the Moon, that is a very specialized telescope that is designed to look very closely at very distant objects. It's primarily being used to look for exoplanets right now, for example. Now, the image of the James Webb Space Telescope is about the size of a grain of dust on my thumb at arm's length. To get my whole thumbnail would require approximately 600 images from the James Webb Space Telescope. The wide field telescopes used in the government surveys can get a larger swath of sky in a single pass, and then it's processed in a manner very similar to what I do. People actually look for moving objects and then measure their locations and their speeds. Now, in the civilian world of amateur astronomy, which is what I am in, we use smaller telescopes. So, for example, a typical 4-inch refractor can get objects down to about magnitude 16, and it's about half a degree by half a degree. It uses a sensor very similar to this one. So you see that small sensor that's in there? That's pretty typical of a standard amateur telescope. Now, I'm kind of in a little different category. I am an official observatory with the Minor Planet Center at Harvard, and I do sky surveys on a more scientific and semi-pro basis. And what I use is an 11-inch telescope of a type called a RASA, a Rowe-Ackermann-Smith astrograph. This is a very wide field telescope. So whereas James Webb kind of gets my thumbnail, I can kind of get an area of the sky that's about 3 fingers down to the first joint. So my patch of sky is about 3 degrees by 2 degrees, and I can get down to magnitude about 20.5 with the right camera. Speaking of the cameras, this is one of the cameras that I use. This is a monochrome or a black and white camera that I use for scientific observations. And as you can see, the size of the sensor is considerably larger than the size of the sensor in the other camera. But even though this is a very large sensor for civilian use, we have a new telescope that was just commissioned down in the mountains of Chile called the Vera Rubin telescope. Now, the Rubin telescope is very remarkable. First of all, it's as fast as my RASA telescope. It is below f2. Second of all, the sensor on that telescope is the largest sensor ever commissioned. If you look at this sensor on this big camera right here, the Vera Rubin sensor is 60 times larger than this. So if you put 60 of these together in a hexagon, that's basically the Vera Rubin telescope. Now, there are approximately 1.5 million known asteroids as of now. We had a lot of discoveries from about 1980 to 2000 because of the advent of computer assistance in searching the images. And it's kind of petered off. It's very rare for us to discover an asteroid greater than 1 kilometer in diameter, for example. It still happens, but there's just not many of them out there. I think we've gotten most of them. The small asteroids, 140 meters in diameter or larger, are what we're looking for right now. And we have been tasked to find 90% of them. These are objects that if they hit the Earth could kind of wreck your day if you happen to be next to where it hits, but they're not end-of-life events. The asteroid that unalived the dinosaurs, for example, was 10 kilometers in diameter. The chance of having something like that in our neighborhood is exceedingly small. This object, this comet that we just found, is estimated to be somewhere between 4 and 25 kilometers in diameter. It's kind of difficult to tell at this distance because comets will have a core and then they'll be surrounded by a ball of dust. And it's very difficult to tell where the dust stops and the comet starts. So the ball of dust is about 25 kilometers in diameter. However, they suspect that the core, the actual guts of the comet, are only about 4 or 5 kilometers in diameter. But fortunately, it's not going to come anywhere near us. But it may come close enough to give us a nice show. You never know. Now, one thing that I do want to close with is the Vera Rubin telescope down in Chile, the one that was just commissioned. I told you that we don't see many new asteroids. It's very difficult to find new asteroids, especially large ones. I have been doing this for 3 years and I have not made a new discovery, for example. However, in the first 10 hours of operation of the Vera Rubin telescope, they found over 2,000 previously unknown asteroids. The key difference between the Vera Rubin telescope and, say, Hubble or the James Webb telescope is it has a very large field of view. It's also about 3 by 2 degrees. However, instead of being an 11-inch aperture like my telescope, it's got a mirror that's 8.4 meters in diameter. And the detail out of it is absolutely incredible. It is on a 10-year mission to survey the entire southern sky. It does that every 3 days and then turns around and does it again and compares each of the images to find things that are moving. As I said, in the first 10 hours, it found 2,000 new asteroids, and that was just the first run. It is estimated that within 1 year, 2 things will happen. Number one, we are going to find at least as many asteroids as we have found in the last 200 years. So we're going to go from about 1.5 million up to about 3 million known asteroids. The other thing that's very important that it's going to do is there is suspicion of a planet X or a planet 9 out there well beyond the orbit of Neptune, possibly twice as far away. If it is there, this telescope will find it within the year. So, this is Bob the Science Guy. Thank you very much for your support of the channel and of the observatory. Our current upgrade projects are going extremely well, and I'll be back with more space news and astronomy news in the future. Take care.